Hi, it's Peter here. I'm just giving you a little talk today about what are numbers, and as we think about teaching senior phase maths, you might wonder why we're having a talk about numbers. Well, partly this comes up because in the senior syllabus, the idea of complex numbers turns up. And also, as maths teachers, numbers is something we sort of take for granted. And indeed, if you ask kids what maths is about, often they'll say it's about numbers. So I'm going to try and promote a little bit of thought about what numbers are and what they might mean, and then we'll think about how that impacts teaching maths. So this shouldn't be new to you, but there's different types of numbers. Of course, there's the natural numbers, which are 1, 2, 3, 4, 5, etc. And they're called natural numbers because, in a sense, these are the only numbers that you can actually find in nature. Then the next are is whole numbers, which is 0, 1, 2, 3, 4, 5, etc. And then there's the integers, which is the negatives and positive whole numbers. And using the word whole numbers there, you see it already could be confusing for kids because we've just called the numbers above whole numbers. But integers obviously are -3, -2, -1, 0, 1, 2, 3, etc. in both directions. I think none of that's new to you. The next one is rational numbers. And again, you know rational numbers as any number that can be written as a recurring decimal or an exact fraction. Right. And then of course, if there's rational numbers, there must be irrational numbers. And the irrational numbers are numbers like pi and e. Of course, this is very confusing for students because all of a sudden we're talking about numbers and we're giving them letters. So at this point here, you can see how for many students, there's some point at which they get confused. So how can e be a number? It's a letter. And then we confuse that even further by saying there's real numbers, which is all the ones above. And if there's real numbers, what's the opposite of real numbers? Well, the kids think it's pretend numbers. Of course, we call them complex numbers. Now, back in the day, they used to be called imaginary numbers for a while. And that's why the number I is used. It stood for imaginary. But, and I being the square root of -1. Now, the question is, well, where did this number I come from? Well, what happened obviously is that someone tried to work out a sum and the answer was the square root of -1 and they realised they couldn't do it. So what did they do? They just made up a number. It's just made up. It's defined because someone defined it that way. Much in the same way, I'm defined by the name Peter. Why? Because my mum just decided that's what I was going to be called. There's no reason for it. She didn't look at me when I was a baby and said, oh, that definitely looks like a Peter. It was just a name that she liked and so she gave it to me. Square root of -1 is I simply because someone decided it gave an answer to a question that they didn't have. Now at this point, it sounds a bit bizarre for students, as you can imagine. And even for some of you who may not have taken a strong mathematical background, more an engineering or a statistical background, it might even seem a bit ridiculous to you. But in essence, it's no more ridiculous than a half. Because if I asked you to show me a half, normally what people do is they get an orange and they cut it, or they get a pizza and they cut it, or they get a piece of paper and they rip it. Now in essence, let's choose the orange for example, when you cut an orange and you show it to me, you're not showing me a half, you're showing me 2. The number that describes that set is 2. There are 2 things in it. The half only describes it in relation to the whole. So a half is not a real thing, it's just an idea we've made up to help us talk about when we divide 1 into 2 equal parts. So a half is no more a bizarre idea than I, or E, or pi, or anything else. This is a really important point because somewhere along that list of numbers we've got there, students get confused and they don't make sense anymore. So very quickly what we need to establish is that numbers are really just ideas or concepts. They're not real things. They only help us describe things. And in fact, the numbers we've got are really only arbitrary and made up because of historical reasons. For example, in some cultures, they don't have the number 0. You don't really need it. What does it do? If you have a little clicker here, you say, I've got 1 clicker. Well, you don't even say 1. You don't need the number 1, actually. You just say, I've got a clicker. But if I haven't got one, I don't hold out my hand and say, I've got no clicker, or I've got no dollar, or I've got no anything. The number 0 doesn't serve any purpose except for place value. And that's, in fact, where it was developed. Or to describe your bank balance, maybe. And the number 1 is not evident in some cultures. Like I said before, you don't need the number 1 because if you've got a clicker, you just say, I've got a clicker. You don't say, I've got 1 clicker. So often these cultures will have the number 2. They may have 3, and then they might say 4 or a few, many, lots. So numbers are just ideas that help us make sense in the context of which we live and work. In our current technological Western culture, we need all the numbers we've got. And in fact, all the numbers that we've talked about so far, including I and pi and e, are all exceptionally useful in different contexts. Interestingly enough, historically numbers have not been the same. We have a base 10 numbering system, but really you can probably work out why we've got a base 10 numbering system, and it's got something to do with the number of fingers we have, I imagine. But if we were going to choose one, 10's not the best we could choose. If we chose a base system of 12, would have been easier. And increasingly now we use a base number system of 2. If you're working in any sort of programming language, it's either 0 or 1. So numbers are just ideas and concepts. And when you come to teach students about complex numbers, it's just another idea or a concept. It's not a real thing, other than we've defined it to be that way. Now some of you might, well maybe you haven't, but this is a book I read. It's about the number 0, and you might wonder why they can write a whole book about the number 0. Well, in fact, historically, many people have died for the number 0 because it was such a radical concept. And in the context of which it was developed, it became heresy. So if you're interested and you've got nothing to do and you can't fall asleep on the weekend, there's books or websites and various things about numbers like 0. And this one's called 0, The Biography of a Dangerous Idea. Interestingly, other numbers like prime numbers are used extensively in coding and not so much coding, but in ciphers and encrypting things for security. So the main reason I've done this talk now is you're going to be coming up in senior maths with the idea of complex numbers, and students really struggle with it. So I want you to start thinking about numbers as ideas and concepts rather than things. And so here's some activities we're going to do in the course. A chapter from that book, I've copied it and I've placed it in the course site if you want to have a read. But in the discussion board, I've got 2 questions posed there, and I'd like you to respond to these questions. The first one is, why do you think students struggle to understand complex numbers? What makes it difficult? This is an important question for you as you think about senior maths, because this is one of the topics which you have to teach and you might find students struggle with conceptually. They can often do all the little routines and tricks and algorithms you want them to learn, but they don't necessarily grasp the meaning of it. And so then the second question is, how could teachers make the concepts more accessible? And incidentally, the answer to that is just not teaching them more algorithms to deal with it. It's important they can do some of those algorithms, but what gives them a foundation for studying it and why is it important? So I hope you found these ideas a little bit interesting and they help you in your development as a senior maths teacher. Thanks for watching, and I'll see you in our workshop sometime over the next week.